This video is going to look at three of the more difficult rules of indices and look at why they work and then how we can apply them. So the first one is that a to the power of 0 equals 1. Now as a here is a variable, basically we're saying anything to the power of 0 is 1. So why would that be the case? Well, let's look at what happens if we, for instance, do 2 to the power of 6 divided by 2 to the power of 6. So what happens when you divide something by itself? Well, you get 1. So hopefully we know that this must be 1. But why can this also be written as 2 to the power of 0? Well, from the first video on rules of indices, you should know that when we are dividing, we can subtract the powers. So this can be written as 2 to the power of 6 subtract 6, which is 2 to the power of 0. So 2 to the power of 0 is the same as 2 to the power of 6 divided by 2 to the power of 6, and we've already said something divided by itself is always 1, so that must just be 1, and that is going to be true for any number. The second rule we're going to look at is that when we have a negative power, then that can be written as a reciprocal. So why does this work? Well, I'm just going to look at powers of 2. I'm going to look at descending powers of 2. So 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. So we're going to do that to start with. So what's 2 to the power of 4 is 16, 2 to the power of 3 is 8, 2 squared is 4, 2 to the power of 1 is 2, 2 to the power of 0, well we've just looked at, is 1. So we're halving each time. If we think why that is, well we're multiplying by 1 fewer 2 each time. So if I continue that, I'll get half, and then I'll get 1 over 4, or 1 over 2 squared, 2 to the power of negative 3, 1 over 2 cubed, and so on and so on. And I could do this with any power series. It doesn't have to be powers of 2. I could use 10 or 5, whatever. It's not going to change it. So if I, for instance, had, I don't know, 6 to the power of negative 3, I would be able to rewrite that as 1 over 6 cubed. And now we're going to look at a root. So this is perhaps slightly more awkward. So I'm going to look here that a root, so I'm going to look at square roots to start with, is the same as a fractional power. So let's have a look at what is 2 to the power of a half multiplied by 2 to the power of a half. Now we know from the first video that when we are multiplying we can add the two powers together. So half plus a half is just 1, so that is the same as just 2 to the power of 1 or just 2. And I also know that when I times something by itself, I can write that as something squared. So I can write it like this. And then I'm going to take a square root of both sides. So if I square root the left side, I cancel out the squaring, so I've just got 2 to the power of a half. And if I square root the right side, I'm just going to write that as root 2. So 2 to the power of a half is the same as the square root of 2. So a root, or a square root, is the same as the power of a half. Now I could do exactly the same idea to show that a third or a quarter would be a cube root or a quartic root, and so on. So let's look at an example of a particularly nasty kind of question on these indices rules. So I'm going to look at 9 over 16 to the power of negative 3 over 2. And this is about as nasty as it's going to get, really. So I've got several rules I'm dealing with here. I've got a negative, so I'm dealing with a reciprocal, and I've got a root because I'm dealing with a fraction. So I'm going to deal with the negative first. So I'm going to rewrite this. So this is the reciprocal, so that's going to be 16 over 9 to the power of 3 over 2. And then I'm going to deal with this square root bit, which is the over 2, so then that's going to be 4 over 3 to the power of 3. And then I'm going to cube both of these, and that's going to give me 64 over 26. 27th.